All right, guys. So in the first part of the recording, you all saw how I have created the training data. Okay, wherein using the document list and the class, I have made the data, converted the data from string data, okay, words or numbers into binary vector, which is ones and zeros. Okay, if you haven't seen the first part, go ahead and check the first part of the recording where I've explained everything. And now going further, once we have this training data, okay, what we are doing next here is, okay, I took the entire data and put it into one under one function, wherein we are taking the JSON file, which is intent JSON file, and then converting the using the first function, which is word cleaning. In we again over here, it is using the same intent JSON file, which is passed in the which is passed into the function, and it gives out three outputs, which is documents, class, and words. Further, with this document, class, and words, with these codes, we are creating training file, which is further divided into x and y. Train x and train y. X is the input, which is the feature, and y is going to be the label. Okay, so after splitting, this function gives out these two things, these two um, data, which is train x and train y. Now this has to be fed into a model. So in order to create the model, let me take you to this these codes. Okay, so I've used a sequential neural network. I decided to build a sequential model with neural network. So I've used sequential, and after doing a couple of R&Ds for a couple of days, creating many layers and reducing the layers and providing the input shape as train X using different activation and different parameters, I finally came to a conclusion that this is the best fit for the model that I'm looking for. So what I've used over here is one dense layer with 128, you can say, the columns of input um, in the dense layer, where the input shape of this train X will be fed. Okay, so the train X will come and then it will go into 128 inputs of the dense layer, and it will get activated with the help of ReLU. Okay, and kernel initializer I've used as a uniform, and then I'm dropping out 50% of the data, and then again creating another dense layer with 64, because when I drop the 50% of the data out of 128, I'll be the remaining data input will be 64. Then I'm using the 64 again into a dense layer, again using the relay activation, and then dropping out 50% again, and from the remaining I'm getting the answer, which is activated with the help of sigmoid, which gives the answer in yes or no, basically. So sigmoid usually gives you answer in yes or no, but this one, when we use the training data, it will give the answer with the help of all the classification that is there, which is 15 classification. So it will basically give out a tag. So after building this model requires a optimizer. So if you can see over here, I've used, in the beginning I used SGD optimizer. I used several different parameters to try and test. Again, spent a couple of days on it, and then for many days, almost half of the project tenure, I've used SGD as the optimizer. But later on, I also decided to play with this more, so I used Adam. And Adam optimizer was not that good compared to SGD. And then lastly, when I came across RMS, I realized that RMS is even much more better compared to uh, the other two. So right now I'm using RMS. If you can see here in the model file. Okay, after creating, if you can see in the model file, this is the first function that we spoke about, that I spoke about in the first recording, and the second one, which is training data. Okay, now what we are looking at is the model creation. So over here I've used RMS as the optimizer, okay, where the learning rate is 0.001. It still works good, and it gives the proper accuracy of 99%. So what I'm doing in this in these codes are compiling the model. While compiling, you need to mention what is your loss function, because this is what it calculates. So the loss function can be RMSE or MAE or many other loss functions are there. I'm using binary cross entropy optimizer as RMS, and the matrix is finding the accuracy. Okay, so after compiling this model, I'm fitting the X data and the Y data, which is in the form of an NumPy array, converting it into a NumPy array. So train X and train Y, and the number of epochs that I'll be giving and the batch size, I've kept it as a variable EP and BT, because I have put the entire thing into a function. In the function, I give as an input to the function, I give the X data and the Y data, and then the learning rate, what it's supposed to be, what is the number of epochs that is going to be, and the batch size. So this actually, if I run this function, and then if you see, I'm using the function which I just created, model training, inside which I'm giving train X, train Y, and then the learning rate that is going to be, and then number of epochs and the batch size. Once I run this, the model gets trained, and as and when the model is uh, processing, you can see the accuracy goes up to 98, 97, 96. So this is the accuracy that I'm getting. So basically, on an average, we have 98% of accuracy in this. So in this way, the model was created, okay, and I have kept all this codes related to the model, which has three major functions, which is word cleaning. Word cleaning function is used in the same file, nowhere else, and which is over here in the next function. And this training data function is used in uh, in the main.py file, no, main.py file, training and model creation. So these two files are actually used in the main. These two functions are used into the main file. Now moving to the main file, we are done with the model.py. Okay, thing file, and I hope that you people have understood well what it is. Uh, After this, I'll move on to this one. All right, let's see here. So far now, what we understood is how the model was created and how the intent JSON file is created. Correct. So with the help of intent JSON file, I am creating the training data, which is in the model.py. Okay, I'm creating the training data, and then creating the model. All of this is getting used in, let's see where it is getting used. Function. Yeah, not in main.py, it is getting used in function. So in the function.py, what I'm doing here is, again, I've taken the required libraries which I mean the libraries that will be required for the codes below. Okay, because I have split the main.py file, and from there, when I picked up a couple of codes and put it into a new file, based on whatever codes over there, I'm using the import function, import library based on the requirement. And then again, if you see, there's a lematizer here, Keras model is here. So what I'm doing is the again, I'm downloading the okay, in the model.py, I did not download anything, any file, because over here there is only functions in this. There are only three functions over here. Now when we are using these functions, then we really need the data in place. So we need this intent JSON file in the form of intent. We need the word which we actually created with the help of the codes, which was converted into pickle file. Okay, so we already have that. And if you do not have these pickle files created, then since these codes were converted into the function, okay, when you run for the first time, when you run the program for the first time, it will automatically create these pickle files, which is over here. which is your class pickle, and then your word pickle, and your docs document. I think there's only two, words and classes pickle file. So what I'm doing in function file is I'm taking these, I'm loading these files again, intent, words, and class. And with the help of the with the help of a function here, again, I assuming that we are getting input from the user, and this input will be put into this function. This function I've named it as cleanup sentence. So what this function does is, now see, whatever we did in the model building procedure in order to build the training, we have to do it all of them again with the input that we are going to receive from the user, so that we end up with the same kind of vector which we'll be putting into the model and then getting an answer. Okay, so we are supposed to make that bag of files which is just created here in this. If you remember, we created a bag here. Okay, and then an output row was created. This is the input and this is going to be the output. First we give x and y both to the model. The model learns, and now in order to test the model, what we are doing is every input that is going to come from the user, that sentence, it will be first tokenized. So this function is what it's doing is tokenizing the sentence into words and lemmatizing it, and then giving out a variable which is sentence underscore words, which has all the words of the sentence received from the user. So this is one function. Now what that function, where it will be used, you will get to see this soon. There's another function that we created. This function creates bag of words, BOW, bag of words. Now what this does is it takes the sentence from the user, and then the word, which is the word file from the pickle that we pulled out, and uh, yeah, these are the only two things it will take. And with the help of the sentence, we will use this first function inside this. Here it is, cleanup sentence. We will give that uh, original sentence of the user to this function. This function will give out the words, tokenized words. Okay, and then with the tokenized words, over here we will prepare a bag. The bag will be uh, in the beginning, it will be a list of all zeros into number of the length of the words. So in this, the word file which we pulled out from the pickle, which had 112 words uniquely, uh, so this is actually getting multiplied with 112. So you will have a list where you have 112 zeros. Now there will be a for loop wherein we will check inside the sentence word and from the sentence that the user has given to us, and we have converted that into tokenized words. So inside that tokenized words list, we will check each word, and for each word we are checking if that word is in the word list that we pulled out from the pickle. Okay, pickle.file. So we are checking over here with two for loops. Okay, with enumerating and trying to search out the index for it, and we are comparing if the W in the words, which is words, the items in the word file, and the S, which is the items in the sentence word, which is from the user now, if they are equal. In that case, when they are equal, then the bag will be bag item, that is each zero, okay, will be marked, whatever zero the index it belongs to, that will be marked 1, rest will still remain 0. So if the sentence has like 10 words, okay, if the user says, okay, I'm looking out for a personal loan and I'm looking out for so and so amount, so if the user gives out a sentence which is of 10 words, the words are tokenized, and all the stop words are removed. Then you, for example, if the list of words now are there, after removing the stop words, it's only 6 words remaining. So these 6 words, where these 6 words belong in the word list, the original word list of 112 words, each we have created a list of 112 zeros with the help of the length of words, and then the each word, which is now a zero, depending upon their index, okay, wherever the word belongs, the user's word belong, it will be marked as 1, rest will be 0. So that's how we get a bag of array, which is equal to the input, which is for which the model is trained. Okay, so now we have a list of ones and zeros, which is a total 112 digits, and it has few ones and couple of many zeros. And based on that input, the model will decide which tag belongs to this list, or which tag output belongs to this list. So now with this function, what I'm doing is I'm just taking the sentence and word list and creating the bag of word for the sentence that the user has given. Next one, what it does is predict the class. So now till now over here, we just got the bag of words. Now we are going to use this bag of words and put it into the model. So over here, again, I'm taking sentence and the model, which was saved in H5 format in the previous uh, function. So over here, we are taking the model, okay, which the model will be okay. First, what we are doing is we are taking inside P, we are taking the bag of word, and this BOW is the function. We are giving the input, which is sentence and then words. Okay, these are the two input that we are giving. Okay, so ideally this word should be over here also. Okay, so we are actually taking in word, words, sorry, words, and then sentence, and then the model. Three things we are taking in this function. First, the sentence is given to sentence and word is given to the bag of word function. Inside bag of word function, the cleanup function is also there. So all these three functions are getting run at the same time. Okay, one nested in each other, and then we are using the response. Res is the response with that we receive from the model dot predict, and then train x. Usually if you remember, the test x is what we give here in machine learning, model dot predict, and we put the input as test x. So this np array, which is a numpy array for the p, which is the bag of word we just created for the sentence that the user gave, and that to the first part of the bag of word. Okay, sorry, the bag of word given, and the first part will be the response. Okay, so there is a threshold criteria that I've made, which is 0.5. So what the result that we get from the model is in the form of probabilities. So the model will give out, since there is 15 class, it will give out 15 answers, and all the 15 answers are the probabilities of where the input belongs to, where the sentence belong to, which tag. So what we are picking up over here is the maximum probability of where the sentence can belong to whichever class. So if the probability, even if the maximum probability is less than 50%, usually the probability is 90 and above. But if there is no sentence which is there in the intent JSON file which the user has mentioned, and when the model tries to convert that into bag of word, and then the bag of word is given to the model, and it tries to search out the class, then in that case the probability answer received from the model, all of them will be less than 50, and one of them will be the highest, which is still less than 50. So in that case, we are actually giving no output as a return. So what this predict class does is actually provides the class where the input belongs to, where the user's input belongs to. So over here, what I've done is, based on the threshold, I'm looking out for a result wherein I and R, for IR and enumerate response. Okay, if R is greater than the threshold, only then the result, it will be saved in the result. So then we are sorting it out. Okay, over here, and then returning the list. Now, what is in this list? So for R in the result, that means all the tags that we have got, all the probabilities that we have got in the result, which is greater than 50. Okay, we will be checking out for the class, and the last one, probably the biggest probability over here, will be returned into this list. Okay, I hope you people are able to understand, because in order to give a demo for each codes here, I will have to go to Jupyter Notebook and I have to run that, and that will take a long time. And the recording doesn't allow me more than 30 minutes. I don't want to make this recording quite long for the entire program. So if you haven't understood what is happening still, all that you have to do is take these codes inside this file wherein you have already run the above files. You have run the above codes from till here. It has to be the same. Okay, till this part it has to be the same. You have to run each and every code, and then below you can take these codes to understand if the user how the user file is getting. I think I might have these over here. Let me try. So this is how the chat model is taken. We have loaded the model into the variable model, intent JSON file into JSON, from pickle words into words, and pickle classes into classes. And then I've spoken about this function, and then the POW function, okay, and then the predict class. Now to see what is happening, okay, if the sentence is say what is your okay, let's change the sentence. If I put the sentence, I need a personal loan. If I put this sentence, then in that case, the sentence will be first forwarded to the function which is BOW, and from this BOW you will get the um, NumPy array or a bag of word in which is stored into the P. Now this P is converted into NumPy array and fed into this model.predict. Okay, and if you want to see how this res, which is a reply from the model, looks, here it is. When I run this, the res is this is the one. Okay, so we have 1, 2, 3, 4, 5, and like this we have 3 lines. That means 15 outputs is there. So what we are doing here, we are using the threshold. I've used here 0.9 directly, and then in with the threshold and with all these codes, I am just getting the last answer, which is this part. This part gives me the answer in the form of intent and probability. So it says that I want loan is belongs to the class which is want personal loan. This is the class where it belongs. This is the tag where it belongs to, and the probability was 0.99. This is the maximum probability, and that's why it has been kept. This is the result. So we are actually pulling out the maximum probability where the input belongs to. So if I give another sentence here, like I have been charged late fee, and if I run, then if you see, the intent is charged fees, and that is the tag, and the probability is 100%. So this is how the model works. It whenever it takes an input from the user, it finds out where this input belongs to in the intent JSON file, where this intent belongs to. Like for example, if you see charges, goodbye is there, personal loan. So here, if you see, I need a personal loan. When I type this, okay, it shows that this is the place where it belongs to. This is the class that the patterns belongs to, and then it will pick up the response from here. So when I type I've been charged late fee, then it picks up this tag, and the response will be from this one. So in this way, the model is prepared. I hope everyone is clear till here. And let me have a check on how long it's been that I'm recording. There's no way to check. Okay. Oh, this recorder doesn't give me a timer. Anyways, let's move further. And as soon as 30 minutes are over, I believe the recording will stop. Then I'll start from there. Now, in the function.py file, what is the next thing that I'm doing? So let's talk about uh, context. Okay, so context. What is context? Now, context is something that I thought of. Like, for example, till now, if you have understood the model, whatever user types in or says, the answer will be given accordingly. If the answer or the user pattern is not there in the intent JSON file, then it will say, okay, I did not understand. So obviously, in intent JSON file, not every type of sentence that a human being can talk is, stored. That is not possible, right? So that's the reason I've put the default fallback intent over there. Wherever any sentence which is not understood, or it's not there in the file, not there in the training, or the model is not trained for, then it will say I did not understand. Because this chatbot is only related to banks, so we are expecting the chatbot to not bother about all other types of conversation, because anybody get coming to this chatbot will only talk about personal loan, because it is a personal loan department's chatbot. Nobody will talk about how is the weather, and talk about more invention, or any other topic which is not related to the motive of this chatbot. So even in that case, if anybody does, I have taken care of that issue as well, but I'll talk about that later. uh, Before that, what I want to explain is the context part. Now, what is context? Context is something, uh, a topic in on which we are actually talking. So if we are talking about the chatbot, and suddenly I start talking about football game, or and suddenly I switch the topic to from football game to a cricket game, then it would not make sense to the people who are listening to my conversation. They will be like, what is he talking? Sometimes he talks about this, and sometimes he talks about that. In the same way, whenever you talk with the chatbot, whatever question you gives, or whatever statement you give, it gives the answer accordingly. So if you say to the chatbot that, hi, I'm looking out for a personal loan, then the chatbot will say, thank you for showing interest for a personal loan product. May I check your eligibility? And when it says, may I check your eligibility, you are supposed to say, okay, yes, fine, go ahead and check my eligibility. Or you can say, no, I don't want you to check my eligibility. But if the person says, do you have credit cards? Okay. Or if the person says something else, you know what, I think you are a robot, you're not a human. So for each question there will be answer, but there is no context. Okay, there's no topic. So you can ask a question like, are you something like a question related to the product, and the very second question that you have is not related to the product. You're talking about, are mountains higher than hills? Okay, and the chatbot, if it has the answer, it will give it out. So the chatbot uh, will not work like how a human being sticks to the context of the topic. So whenever you're talking with another human being and you're talking about something, some topic, and suddenly when you switch the topic without completing the conversation, the opposite person will say, hey, what happened to you? You were talking about this. So say, for example, if I'm talking about a movie, and we are talking about a movie that is Golmaal 3, and this suddenly we are talking, and the conversation is going, and suddenly I switch the topic from Golmaal 3 movie to a football game. Then the opposite person will be shocked and surprised. What happened? He was talking about Golmaal 3, and suddenly what is that? So that is context. The conversation, whatever happens, it has to stick to the context till the time the conversation is uh, completed, or it is slowly switched to another topic. There are a lot of times when the conversation happens between two people, a guy or a girl, and then they start with something and they end up with something else, but the conversation switches smoothly from one context, one topic to another topic, and from another topic to another topic, and with their own agreement. And no one between the people who are talking, they are never surprised why the conversation is getting switched. So that is something we wanted to take care of, because since this is a pure like a machine model, whichever question you give, the answer will come out in that way. And the chatbot is not expecting for a particular type of question to come, and it's ready with all the types of question. Whatever question you give, whatever statement you give, it gives the response, and it may not be connected with the previous answer. So if I say to the chatbot, okay, I'm looking out for a loan, the chatbot will say, okay, fine, let me check your eligibility. Then if I say, you know what, I want to foreclose my account, so it will say, okay, let me check what is your foreclosure amount, and it will keep on going on. It will not care what you are actually talking, why you're switching the topics again and again and again and again. It will never come to an the conversation will never come to an end. So that's why the context part was brought into the picture. So I'll tell you how we handle the context over here. So after predicting the class, once we have the class and it gives the response, okay, in order to give the response, first, uh, this is the function that was created. Okay, in order to give the response, so it will give the context response, which context it belongs to, that response it will give. So this takes the query, which is the sentence from the user. It has the tags, okay, and a user ID, which is some number 123, and the intent JSON file. Okay, so before we get into this, let me explain what tags. So if you have understood when the prediction is done, this prediction of the class is done, it returns the result of in which the result looks something like this, where the result is a list. Inside this list, there is a dictionary. If you can see, there's a dictionary inside one list, and this dictionary has two items. One is intent, and the value is charges fees. Okay, so this is the key and this is the value. And then the next one is probability, which is the key, and the value is this one. So what do we need from here? We just need to know what is the tag, what is the class that has been found. So all that we need is from the answer is the first entry in the dictionary, and that too only the value. How do we get that? From this return list, which is the entire list, has two keys and has a dictionary and has two keys and values. So what we are doing is we are actually taking that and checking if the tag is has the same context or not. So before I go to the context, now you will still think, how do we check that? So let's go back to the intent JSON file over here. If you see uh, greetings, the let me make it big. Okay, so if you see the first class, which is the first tag, which is greeting, it has all these patterns and it has this response, and then it has something called context set. Context set, what it does is it will set the context with the help of another function. Wherever in a intent in a dictionary or in the okay, we call that as intent, all these dictionaries, small. So whenever in any intent there is a context set, then the context will be set with the value which is under that. Now this has no value because it is just a greeting. But if we go ahead and check any other, like especially the topic on which the conversation can happen, which is personal loan, there's a context set inside this, and the context set value is personal loan. If you talk about charges, then the context set will be charges. If you talk about top-up loan, then the context set will be top-up loan. In this way, how we will, if you talk about foreclosure, the context set will be foreclosure. So in this way, the context will be set. Now, before setting the context, or how we are setting the context, is in this way. Okay, this function will tell you how we are setting the context response. I'll come to that, but before that, there are a few things that I would like to cover. Okay, we'll leave this function for now. It is reconfirming because basically this is a function which reconfirms any input taken from the user if that input is supposed to be an input for a model. Okay, for a model that does something. This function is get tag. Now what this does is it actually gets the tag out of the result. So this ints, which is the integers, is supposed to be is actually the result from this predict class. So whatever comes out of this predict class, we will take it as this variable as int. And over here, if you see, The tag is supposed to be int's first item, and in the first item the keyword is intent. Okay, I'll show it over here again. Inside this, the first item is this. Okay, this dictionary, the first item is this, and the keyword is intent, and this entire list is thrown out of this function, which is predict class. So after getting the result from the predict class, what we are doing is we are taking the result into this function, which is get tag. And this function, what it does is it actually pulls out the tag out of it, and it gives it as a result. It throws out as a result. Now, what are the rest of the codes doing? So there were a lot of issues when we were getting the tags. So most of the tags, like for example, if the tag is completely empty, okay, when there is no sentence matching in the intent.json file, the tag will be empty because it will not find any tag. If there is a sentence which is, if I say this to the chatbot that do you know in America there are elections going on? Obviously, there is no such sentence stored in the intent.json file, so it will try to search out the sentence, and then it will say there is no tag found, and the answer will be empty list. So there will be a list, but it will be empty. So whenever we find the list as empty, then the tag is supposed to be default fallback. See, understand, all that we are trying to find is the tag from which a response can be pulled out. So default fallback tag from this tag, if we get this tag, the next function, what it will do is it will find out where this tag is. I think the recording has stopped. Pause. Okay, maybe the recording is not stopped. Let's continue with this. Share the screen. Okay, so yeah, so the default fallback tag is over here, and if you see, the pattern is empty. So if there is nothing found, this doesn't mean anything, because what we are actually doing is a function which where the result is empty. So all that we get is in return, if the result is empty, let the tag be default fallback. So with this tag, what the next function will do is it will search out for the tag which has the same name, default fallback, and it will give any response from here. Okay, now the next thing is what are other if and else statement doing here? So till here, if you see, till here, it's in one if and else statement. What it does is it just simply takes the query, whatever is the answer from the user. I've created two separate lists. One is for yes and one is for no, because most of the time there will be a reason, there will be a requirement where we will have to um, the questions will be completely based on um, the answers which is yes or no. Okay, so there will be a lot of times when the chatbot will be looking out for a yes or a no answer from the user. Well, in that case, what will happen is uh, we cannot keep on making separate intent JSON files, intent JSON in separate intents with different live dictionaries with yeses and nos for this reason, yeses and nos for that reason, and so many times we will have to make yeses and nos, and still it's not going to work, because when the training file runs, it will see that all of these intents will have the same patterns. Okay, the patterns will be same, all the yeses and all the nos. So it does, the model will get confused. So that's the reason we cannot put yeses and nos, all types of yeses, like yes, okay, yep, okay, fine, cool, sure, all right, yes, please, go ahead, positive, okay, okay, man, of course. All these types of yeses and all these types of nos cannot be the same in pattern in different tags. So that's why I came up with this way of just making a list, and then whenever you get a query, which is query is the input from the user, we will check if the query belongs to this list. If there is any yes into this, I mean, if the user is only saying yes, or if the user is only saying no. If it belongs to yes, then the context, uh, the context user id will be, which is I'm putting it into a variable which is con, and to find out what is the context. Okay, because in the conversation the context will be set already, and then I'm using it as a, I'm using this context first part, and adding a little string which is yes if it is found in the yes stream, yes list, and creating a new tag, basically a tag which will have the context plus yes, and that makes a new tag. Okay, so a little bit hard to understand because I missed out one more thing here. Let's come back to this later. First of all, if you've understood only this much of part in this, it's well and good. Okay, this is what this function does. It actually takes the inputs from the predict class function. It takes the input and it throws out only the tag. And if the input is empty, then it throws out the tag which is default fallback. So let's get to the context response function. Okay, I will have to explain this in parts and bits, some parts here and some parts there, because that's how it works. Now what this function does is it actually takes the intent JSON file, which is intent JSON intent part, which is only the values of the intent JSON file, and it puts into a variable called list of intents. And then with the list of intents, we are using the for loop. We're saying I in list of intents, which is the I over here means the each dictionary inside the intent JSON file, and each dictionary has tags, the patterns, the response, and the context set, and all that. So what we are doing here is we are picking up each dictionary, and from each dictionary we are trying to check if the that intents tag is equal to the tag that we got from this above function. Okay, and how do we check that? Is we are actually giving it directly over here. So this gets clubbed into another function where that function is first used, and then we get the tag, and then that tag is used as input for this function. So for now, just understand the tag is already given as an input to this function, and we are checking if the tag is equal to that. If the tag is equal to that, if the tag is equal to that, just leave this part, this entire part, and come to the this elif part here. If the tag is into the I tag, which is the intent tags, then we will check if there is a context set in I. That means if this is the tag which is help, or say for example, let's pick up another one. If this is the tag which is foreclose, and we are checking inside intent, which is this file, and in each the for loop will pick up each dictionary one by one and check if the tag matches the tag that has been provided here, the tag that has been provided here. Okay, this tag matches to any of the tags in the intent, so that will find, okay, if it is foreclosure, then it will find, okay, this is the dictionary. Then from this dictionary it will check if there's a context set. Yes, there is something called context set over here, and it is foreclosure. So what will it do is it will over here use the context user id as I context set. That means there is a list created here, which is a dictionary created here as with the name of context. Inside this we can use any keyword, and the moment I use a keyword which is user id, it will add the value to that keyword, which is user id. Now what is user id? I can give the user id any value, so in quotes. So that you will come to know later on what we have given in the main.py file. So with the help of this function, we are setting the context. So right now, what is the context? It is foreclosure. So inside that dictionary context, there is something called user id, and user id is to, which is in the dictionary how it is, the keyword and the value. So the keyword is user id, and the value is the context set, which is foreclosure. This is the context set. So why do we need that? This is because the next conversation which will come, it will check if the context is the same or not. If the context is different, then it will give a different type of response. So with this part, first it sets the context. Whenever if the context set is in the intent, then it will set the context every time. Whenever there is context set, it will keep on updating it. So next one is context filter. So for example, the intent JSON file is built in such a way that if I talk about, say I talk about personal loan, and I say I need a personal loan, this first sentence, I need a personal loan, and the chatbot finds this into this tag which is want personal loan, and it gives out this response: thank you for sharing the interest in our personal loan product, and can I ask you a few questions for your loan eligibility. Now on this question, what will I answer? When it says can I ask few questions to check your loan eligibility, what I will answer is either yes or no, right? So the moment I answer yes, over here, what happens is this function will check if the query belongs to yes every time. Everything that I say, it will check it belongs to yes or no. If it belongs to yes, then what it is doing, it is checking if there is whatever is there in the context. So what was the context set earlier? Say for example, it was set this. Since want a personal loan, then it will be set as personal loan. So it will check the context set, and it will put it into a variable called con, and then it will use the first part, which is why I'm using the first part over here, because it's in a list. The context set is into a list, and this is the first 0th index. So I'm using the 0th index plus yes. That means now in tag, what do I get? I get personal loan underscore yes. This is personal underscore loan, and then I'm adding another underscore yes to it. Now that will become my tag. So let's see if we have any such tag here. So I've made a tag. Whenever there is a yes, then this is what the model will find out. And by just saying yes, the model will find out this tag and give out this response. Then it will say, may I know your complete name? Please type or say your say my name is, and then your complete name. And in this way, it will continue with the conversation. Once you have this conversation, if you see, the context set is now personal loan apply. Now the personal loan context is gone. Now the context changes, personal loan apply. And now when it is asking for a name, the answer will be what it is asking. It is saying that please type or say my name is. You have to say my name is first and then your name. So if the user says my name is, then here it is. It will find a tag which is username. The model will find a tag which is username, because under this the pattern says my name is I am, and it will give another response. It will say, may I know your date of birth then? And then again you have to type or say date is before the date in the format which is ddmmyyyy format. So the intent file plays a very important role, and these contexts plays a very important role. So if you see, after the username, it is not setting the context. It is, there is something different called variable over here, the keyword, which is called context filter. Now whenever we get a context filter, this has to match the context set. Okay, so what was the context set? So context set was personal loan apply. Okay, over here, see, personal loan apply was there, and the context set, now it becomes context filter. So if I take you here again, next time whenever so once the context is set, okay, the response was given from this part of the code. Okay, next time again, when the response is being searched in this function, the list will come, the tag will search out for the similar tag, and then it will check if there is a context set. If there is no context set, then it will check if the context filter is not in I, or either, yeah, either the context filter is not in I, or all of this. What is all of this over here? It says that if the user ID is in context, that means there is a dictionary here on this page which is the name of context, and it has a user ID. If there is a user ID, and context filter, which we get it in intent, is in I. So context filter also has to be there, and then the context filter is equal to the context in user ID. If all these criterias match, then the response is given from that particular tag. Okay, so which this takes care of the issue wherever there is context filter. Okay, that means the same context has been carried forward with the conversation as that happened in the previous conversation. Okay, previous sentences or question and answers, the same context is carried forward, and that's how it will. See, if the second question also has about net income, the same context filter is there. So till the time the context filter is same to the context set, it will keep on searching for an answer which is in the same context and response basically, and the conversation will go ahead smoothly. Okay, so this two functions takes care of everything when we talk about responding the replies for the query. What are the rest of these? So I wanted, especially for the type of queries where it is asking for the name, the chatbot is asking for the name, age, or date of birth, or income, expenses, name of the company. All this is going to be used as input to the eligibility model, where the model is going to check whether the customer is eligible for a loan or not. All that question I wanted it to be repeated to confirm. So after taking the name, the chatbot will say that, okay, I see that you have mentioned your name is so and so. Okay, is that correct? Then if the user says yes, then it will go further. So every input will be reconfirmed. Now, in order to reconfirm, if you might have seen this function here, okay, I have used it, which I created over here. What does this function do? This function actually takes the user's query, and it adds into this response. It says you have mentioned, and then over here the query will come in this curly bracket. Is this information correct? Please confirm yes or no. The moment it says yes or no, then this function will check, the get tag function will actually check if the answer belongs to in any of these lists. Yes, of course it will belong to the yes list. Then whenever it is yes, then the tag will be changed with the help of the context, where the yes will be applied, and it will keep on going in a cycle. So all of this strategy, all of this um, architecture was very important, and not only important, I would say it was very tough for me to figure out and design it. I have no clue if there is anyone who has done it something like this, but yeah, this is what I have done it. So and I did not get it on any website or any site. I did search a lot of things, but I did not get any answers. All of this I had to make it from my own understanding and my own brain. So there could be there is a possibility that whatever I've done, all these big functions can be probably, shrinked into small things, small function. But I don't know how. If you all can, after understanding this, if you all can actually come up with something like that, that's well and good. So basically, this tag function takes all the possibilities of the tag and gives out a one single tag at the end. Now when we are checking, okay, after every conversation, after every input, whenever there is a check that happens, so I have used this recheck as one of the keyword in the tags. If you can see, total experience recheck, okay, and then company name, then recheck. So total expense recheck. So this is one of the keywords which are not all tags will, or not all intents will have, but few of them. So what this does is, every time whenever we find the match of the tag in this context response function, when we find the match of the tag in the intent JSON file, we will also check if the recheck is in I, which is recheck is in intent. If there is a recheck in intent, then that whatever is the reply, okay, over here, if the query is not no, if it is no, and the context filter is equal to the context user ID, if these criteria meet, if the query is no, then it will repeat the previous response. Okay, it will just repeat the previous say for example, if the chatbot is saying, may I know your complete name, and please say or type my name is, and then your complete name, and the user says something, okay, my name is Vinod Kumar, and then the chatbot repeats, reconfirms with this. So because whenever the query is not equal to yes, and it has a recheck in the intent, it will use this function to reconfirm. So if the user has said my name is Vinod Kumar, the chatbot will say, you have mentioned that your name is Vinod Kumar, is this correct? Please say yes or no, or type yes or no. So if the customer types no, then what the chatbot is supposed to do? It is supposed to ask the name again, right? If the customer says yes, then it is supposed to go to the next question. So for that reason, this function, this if function is used if whenever the query is no, and the context filter is equal to the context user ID value in the context dictionary. In that case, the response will be the same response for the tag, okay, where the tag will be appended into the recheck tag. So there is another list of tag that I'm collecting in order to check how many times the recheck is happened. So whenever there is any tag in the recheck, this is how it gives out the tag. So in the tag function also, we are actually checking all these types of or giving out all these types of tags. And once we have the tag here, here is when we get the tag. After getting the tag, we are checking over here if the tag is in recheck tag yes. So recheck tag yes is here. Okay, so I've just put one for the moment. Okay, if there is recheck tag yes, then what to do, and if there is recheck tag no. Because what happens is whenever there is a yes or a no answer, it takes the context which is personal loan apply, and adds a yes to it, okay, over here, or a no to it. So if it is no, then this will be the next tag. So whenever if the tag is in recheck tag yes, then the tag is supposed to be the last tag in the recheck tag list, which is here. In this list, when we are saving, the tag is supposed to be the last one. And if the check if the tag is in the recheck tag no list, then the tag will be from the all conversation tag, the second last one. So there's another list that where I am collecting all the tags that is happening in the conversation, all the classes or all the tags. So for example, if I give you if we are into a conversation with the chatbot, and the chatbot has found the tag is supposed to be username. When the username is the tag, the response from the chatbot will be asking for the date of birth. Why the username is why the tag is username? Because the user mentioned my name is, and whatever his name is. So that response, when it tries to check into the intent JSON file, it finds that the tag is username. Under username tag, if you see, my name is what the user has said, and under username tag there is responses, may I know your date of birth. So now when the customer says his date of birth, my date of birth is, or date is, then it will find the tag DOB. In this way, the tags are getting saved. But say for example, the last tag saved is username, and now it is asking, is that the right name that you have mentioned? And the customer says no. Then there is another question again. The question is repeated, then can you please provide the name, complete name? Then again the customer says my name is. That means username gets stored twice. Okay, in that case, we want how to repeat the first response. In that case, we want these lists, and from these lists, sometimes I'm picking up the last one, or sometimes I'm picking up the second last one tag, in order to get a proper response. Now this is another function which is called tag path checker. Okay, we are checking the path of the tag. The tags are supposed to move in a particular pattern. If we want the chatbot to take all the proper inputs, and then record all the inputs and give it to the model which requires those inputs, like for example eligibility model. In that case, we want the the function where we can keep a track of what all tags are happening. In that case, we need uh, another file that I created, which is conversation.json. In this, there is a pattern of the conversation that should happen. So if there is something called personal loan conversation that is happening, PL conversation, yes, about conversation about personal loan, then the first tag should be want the personal loan, because the customer is looking out for a personal loan, right? If the customer is already a customer, then this story, this you can say see it as a story. This there will be another story for that person. For that, and that kind of another story can be created. I've just created one here, and what this story does is it takes the chatbot according to this pattern. So first, it is expecting this tag to come from personal loan, wants personal loan, and if the customer says yes to this, then this will be the next tag, wherein the customer has said yes to the to check the eligibility. If the customer has said yes to check the eligibility, the next tag should be username, wherein the chatbot will ask for the username, and then from username, date of birth, and from date of birth to. So this is how I have created a story. This is one complete story. After taking this much information, after total experience, I am supposed to add more over here, because after taking this, it will give out the eligibility, and then after giving out the eligibility, it will ask whether the customer wants to apply for the personal loan. If the customer wants to apply for the personal loan, then so each time that story will change. All of this is based on yes. So that is why it is named as personal loan conversation yes. Whenever there is a no that arises, then there will be a different story altogether. So these stories, they will be like, at least 50 to 60 stories that we'll have to create based on all conversation, all possibilities of conversation that can happen for these products. How many products do we have over here in personal loan? What all type of product? What I mean by products is the type of conversational products that can happen for a personal loan. So what we have taken here is either the person is looking out for a personal loan, okay, want personal loan is one. There can be a huge conversation for this. Either the person is talking about a late fee charged on his personal loan account, or either the person can talk about top up loan or foreclosure, loan application status. Okay, so these are the only topics that we want to cover in this chatbot. Once we have covered all these topics, then a chatbot is done. Chatbot project is done. Okay, for now, I'll just end this conversation or this session over here. Okay, and let me check if it's got recorded. For the next thing, after this function, we'll be discussing the main.py file and the eligibility, which I'll do it uh, later. Okay, so thank you guys.